Are you alright, Ethan? Ethan?
Yes, it's just a stupid banana peel.
But Ethan, you know bananas aren't stupid. Why don't you tell the kids why bananas are very important?
Okay, alright, bananas aren't stupid. Bananas are an excellent source of potassium. And potassium is essential for your organs to function properly, and it is important for us today because potassium is an element.
But what's an element, Ethan?
That's what we're here to find out.
Ethan the Science Man. Ethan the Science Man. Ethan the Science Man. Science rules. Ethan the Science Man.
Inertia is a property of matter.
Ethan the Science Man. Ethan the Science Man.
An element is a substance that cannot be broken down into a simpler substance. Elements are made of a certain type of atom, and when put together, they can form all sorts of things. Everything we know here on Earth is made of elements.
So you're telling me that that table is made of an element? Is wood an element?
Ha, no. But wood is made from elements just like everything else. Wood is made from oxygen, carbon, hydrogen, and nitrogen, among other things. What makes it wood is how the elements are bonded together. Let's say, for example, this glass of water. Water is H2O, which means it contains 2 hydrogen atoms and 1 oxygen atom. But obviously isn't anything like hydrogen or oxygen. At room temperature, both these elements would be gases, but together they make something with its own unique properties. If everything was made up of only one element, we wouldn't have much variety, would we? There are only 118 elements, but together they make up millions of compounds that form everything we know. The 118 elements are categorized in a table known as the periodic table of elements. The table is organized by atomic number or amount of protons that are in an atom's nucleus. The table starts at hydrogen and goes all the way up to ununatium, which has 118 protons in its nucleus. The table is divided into rows called periods and columns called groups. All atoms in the same row or periods have the same number of electron orbitals. For example, hydrogen and helium only have 1 electron orbital, and they are in the same period. Every element in the same group has the same number of valence electrons. For example, in the first group, also known as the alkali metals, they all have 1 valence electron. Whereas on the way other side of the table, in the noble gases group, they have 8 valence electrons. They are referred to as noble gases because they rarely bond with other elements. But an element like, where is it? I'll know I'll find it. Here it is. Carbon has only 4 valence electrons, which means it needs 4 more. Carbon can bond with many things, including itself, in long chains. This is why carbon is found in so many things, and is the basis of all known life in the universe. Like this. Something like sodium, that only has 1 valence electron, desperately wants to give up that 1 valence electron so it can have a full outer shell. So that makes it very reactive and dangerous. Similarly, something like chlorine, that has 7 valence electrons, desperately wants that 1 more electron to complete its outer shell. You may have heard of something called chlorine gas, and it's very dangerous and can be used as a weapon. The octet rule states that most atoms want 8 electrons to fill their outer shell. The duet rule states that hydrogen and helium want just 2 atoms to fill their outer shell. Valence electrons and these rules are the reason for the bonding and compounds we have discussed today. Well, to talk to us more about the elements and chemistry all around us, it's our resident element and chemistry all around us professional, Sam, the Element Man. How you doing today, Sam?
Well, I'm about 99% oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus, if you know what I mean.
Indeed. Tell us a little bit more about chemistry, how about?
Well, sure. The reason our show does so well is because we have so much great chemistry. I'm just playing with you. But seriously, there's so much great chemistry in the world around us. For example, this ice water. I always carry it with me. Why does this ice, H2O in the solid form, float in water, H2O in the liquid form? Ice floats due to something called a hydrogen bond. This is where H2O molecules share hydrogen atoms with each other. In liquid water, these hydrogen bonds are forming and breaking quickly, and each H2O molecule is connected to an average of approximately 3.4 other H2O molecules. This means that H2O molecules bond together and fall into an orderly crystalline structure. This structure has more space between molecules, and the molecules move around making and breaking bonds, and therefore the ice is less dense than the water.
Boom, floating. Wow, that is truly astonishing. Remember, kids, floating ice is totally nice. Put that on screen. Tell me more, Sam.
There's so much to tell, like how I can do this. Isolate sodium and chlorine, also known as sodium chloride or table salt. Sodium is a metal that reacts violently with water and can cause fires due to the hydrogen it releases. Chlorine is a much nicer element that, just reacts with water in your lungs to form acid inside of you, so not much better. Yet these two incredibly dangerous elements come together to form a delicious addition to my food. This is because the only thing dangerous about them is those pesky valence electrons. As I know you mentioned earlier, sodium has 1 valence electron and chlorine has 2 valence electrons. These two elements will quickly and powerfully react with anything that fills their outer shell. When they meet up, however, they've realized that they found the perfect match.
So is this right? Sodium shares its 1 valence electron with chlorine, revealing a full outer shell beneath it. And chlorine takes that 1 valence electron to make its outer shell full.
Yeah. So now the chlorine's negatively charged and the sodium is positively charged. So that means they are
attracted to each other. This is called an ionic bond and is harder to break than a covalent bond. This means sodium chloride stays just how we like it.
Delicious and not tearing our lungs apart. Gotta go, kids. Those birthday parties won't clown themselves.
Bye-bye.
So what did we learn today, kids?
Nothing. This is a chemistry class. We know this.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.